and MYP. Today we will continue with divisibility rules, but before we continue with divisibility rules, revise the divisibility rules that we did last time. So let me share my screen first and then we will start with our divisibility rules. So the first divisibility rule that we learned was by 2. So how to know a number is divisible by 2? So any number that ends with a 0, 2, 4, 6. Sorry, see, this happens when my brain is working faster than my hand. So basically any even number is directly divisible by 2. Okay, you can apply that rule for any even number. Then by 3, its sum of its digits is divisible by 3. Then by 4, last two digits of a number are divisible by 4. By 5, it's the number should end with a 0 or a 5. By 6, number has to be divisible by 2 and 3, not or, and 3. Then by 8, last three digits are divisible by 8. Sum of digits for 9, sum of digits has to be 9. Okay. Now, I also taught divisibility rule of 11, but since it is slightly complicated, I'm going to do that divisibility rule again in details. Okay. So, let's start with divisibility rule of 11. So, this rule states that a number is divisible by 11 if the difference, read it very properly, okay, if the difference between the sum of even placed digits and odd placed digits, and we can write sum of odd placed digits is either 0 or 11. Okay, so we are going to take an example. Let's take a number 10769. So the green ones are odd digits or odd placed digits, and the blue ones are the even placed digits. So how do we know that this number is divisible by 11? So we take 1 plus 7 plus 9 minus 0 plus 6. So it is 17 minus 6, that is equal to 11. So we applied the rule, we tried it, but let's confirm whether what we have tried is true. So I'm going to do the actual long division. This is very important. You cannot forget how to do your long divisions, okay? 7, 6, 9 divided by 11. So we will take 9 times 99, okay? So 107 minus 99 is 8. Then this 6 will come down. 7 times is 77. Then 9 comes down, and this 9 will come down here, and times 9 is 99 and 0. So this number is definitely divisible by 11. I know this is slightly a difficult rule, but this rule is going to help you a lot when we do actual factorization and multiples. Okay. So now we are going to learn about divisibility rule of 12. The rule states that a number is divisible by 12 if it is divisible by 2 and 6. Okay. So here we are going to apply two different rules to see if the number is divisible by 2 and 6. If it is divisible by 2 and 6, we are going to say that it is divisible by 12. It's very easy, right? Same like 6. So we are going to take a number. Take a big number. 21,468. 21,468. Am I correct? Yeah. So now we have to see, is this number divisible by 2? Yes. Is this number divisible by 3? So 2 plus 1, 3, plus 4, 7, plus 6, 13, plus 8, 21. So this number is also divisible by 3. That means this number is divisible by 6. If it is divisible by 2 and divisible by 6, then it is divisible by 12. But still we will check. Okay. So I will say times 1, 12, 94, times 7, 84, 10, 6 comes down, times 8, 96, 10, 8 comes down, times 9, 108. So it is divisible by 12. Now we are going to do a few questions and we are going to see if we can apply these divisibility rules to our given questions. Give me a moment and let me take a few numbers. Okay, so what we are going to take here is, let's say, 153. Okay, and we have to test whether this number is divisible by 3. Is it divisible by 3? It's 1 plus 5 plus 3, which is equal to 9. So it is divisible by 3 and 9. Why? Because it satisfies both the rules. It is divisible by 3 because 9 is divisible by 3 and the sum of the numbers is 9. So it is divisible by 9. Let's take a bigger number. Let's say I have 1002. Okay. Now I know it is divisible by 2. Why? Because it is a even number. So it is divisible by 2. Now let's see whether it is divisible by 3. So it is 1 plus 0 plus 0 plus 2 equal to 3. So it is divisible by 3. Since it is an even number and it is divisible by 3, this number is also divisible by 6. Okay. So why don't we try this number? We have to check whether it is divisible by. So general question is check whether given number is divisible by some number. So let's say I'm asking you to see if this number is divisible by 9 or 3. Okay, let's take 3 first. 9 is a very future rule. We'll say 3. Okay. So how do we check? Again, 5 plus 6 plus 9 plus 4 plus 7 equal to 5 plus 6 is 11 plus 9 is 20. 20 plus 11 is 31. 11 plus 11, 22 plus 9. Yeah. So this number is not divisible by 3. Okay. Now let's see whether we can apply divisibility rule of 4. So let's say I will take a number 1250. Now divisibility rule of 4 states that your last two digits have to be divisible by 4. So I will take 50. Is 50 divisible by 4? No, it's not divisible by 4. So 1250 is not divisible by 4. Okay. If I take number 31560, now I have to determine whether I will be able to divide this number with a 4. Now let's see. My last two digits are 60. Is 60 divisible by 4? Yes. Then this number is divisible by 4. Okay. Now, so this is how we check our divisibility rules. Now next one is factorization. Okay. So you are given a number and you are going to factor it. So how do we do that? That's the reason we learned these divisibility rules. And then we have to find out what is the HCF and LCM of all of this. You know, HCF and LCM, highest common factor and least common multiple. But before that, we have to factorize a given number. So we are going to learn how to factorize a given number. I'm going to take a big number, which is 2520. Now I know that this number is divisible by 2, this number is divisible by 5, and this number is divisible by 10, and this number is also divisible by 4. But when we are doing factors, we generally use prime numbers. Okay. So when someone asks you to factorize a number, they are expecting the number in prime factor form, not a composite number form. Okay. So what I'm going to do is I'm going to show you a tree structure. Okay. So I'm going to divide this number with a 2 first because I know it is divisible by 2. Okay. So I get 1260. All the numbers that I am putting in a circle are the factors. Again, this number I will divide by 2. 630. Again, this number I will divide by 2. It's like making roots of a tree. We are going to the bottom of this. It's 315. We always start with the smallest root and then we go along. Now I know that this number is not divisible by 2, but this number is divisible by 3 and this number is divisible by 5. So I'll take 3 first. So it's 105. Now this number is again divisible by 3. So I will do 3 times 35. Is it? Now we know that 35 only has two factors, 5 and 7. So I will write 5 and I will write 7. Okay. Now, when I finish factorizing this, I am going to represent this number in form of factors. And we always write the factors in ascending order. I will tell you why it is necessary when we do HCF and LCM. Okay. So it's 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 7. So this is how you represent 2520 as your number. Now you have to remember one thing, like in addition and subtraction, if you add an even and an odd number or an odd and an even number, it is always an odd number. Or if you add even and even or odd, it gives you odd number. Similarly, if you even number. So similarly, if you multiply even number into even number, you're going to get an even number. If you multiply odd number into even number, you're still going to get an even number. If you multiply odd number into odd number, you're going to get a odd number. So whenever you are factorizing, you should remember that there is a chance that given number, if it is odd, it doesn't have 2 as its factor. So you don't have to waste your time in using trying to divide with 2. And we also have our divisibility rules which you can apply. Okay, so next we are going to take another number. Let's see, I will going to show you how a square number looks like. Okay. So I have a number which looks very easy, which is 40,000. Okay. Now number is going to take a long time to divide. So I'm going to start with 2 and it becomes 20,000. Okay. Now, how do I know that this number has a chance of becoming a perfect square? Because it has even number of zeros and a 4. So definitely we know the square root of this number is 200, but we have to see how it looks when we are representing in terms of factors. So this is 2. Again, I'm going to divide with a 2. So I have 10,000. Again, I'm going to divide with a 2. So I have 5,000. Again, I'm going to divide with a 2. I have 2500. Again with a 2. I have 1250. Then again with a 2. I have 625. Now 625 ends in a 5. So this number is definitely not divisible by 2. It is divisible by the 5. So I'm going to take this and I'm going to say it is divisible by 5. Then it is 125. Then 125 is 5 into 25. And our last branch is 5 times 5. So we are going to write this number in terms of factors. Why I'm showing this to you? Because it matters a lot how you write a number. So it is 2 into 2 into 2 into 2 into 2. How many 2's are there? 1, 2, 3, 4, 5, 6 2's are there. One more 2 times 5 times 5 times 5 times 5. So we have, if you see now, we have pairs of numbers. 1, 2, 3, 4, and 5. So if you want to find out square root of any number, you factorize it and just take roots of one number at a time. So 40,000. So out of these twos, I will take 1 2. Out of these twos, I will take another 2. Out of these twos, I will take another 2. Okay. Out of these fives, I will take a 5. And out of these fives, I will take a 5. So answer is 200. So this number was pretty easy. But how do we know that any given number is a perfect square? So let's take, so I'm going to take a number which doesn't look like it is going to be easy to find out a square root. So my number is 5625. So visibly, I have 5 over here. So I'm going to start with a 5. So 5625 divided by 5 is going to give you 1125. Again, divided by 5, this is going to give me 225 if I'm not wrong. 225. Now 5, 45. 5, 9. So 3 and 3. Now here I started with 5 because 5, it was easiest to find. But if you want to go by the lowest one, you can start with 3. No problem. Okay. So my 5, 6, 2, 5 is equal to 3 times 3. Again, we are going to write it in ascending order. Times 1, 2, 3, 4, 4 5s. 1, 2, 3, and 4. Now, if I want to find out square root of 5, 6, 2, 5, I will find the pairs of numbers. Okay. So I will take 1, 3 out of this. I'll take 1, 5 out of this. And I'll take another 5 out of this. So my final answer is 15. Now, since we are talking about squares and square roots, I am going to teach you a trick of finding out squares of numbers ending with 5. Okay, in last 5 minutes, let's do that trick. And then we will continue with factors in the next class. Okay, so let's say I have a number 45. I want to find its square root. I want to find its square, but I'm slightly lazy. So what I will do is I will first write 25. Okay. Then I will check this number, this digit, it's 4. So I'm going to multiply this 4 with the next digit in its row, which is 5. And I'm going to write 20. So 25 is the square root of 45. Okay. So let's say 85. Okay. So I'm going to write 25 again. Then I'm going to take 8 and I'm going to multiply it with 9. So I'm going to get 72. So 7225. Okay. We can try factorizing 7225 and see if we really get 85 back. So 7225 divided by 5. What do you get? 1445. Now again this one I'm going to divide by 5. It's 289. Now those who don't know the squares, 289 is square of 17. Okay, so it's 17 multiplied by 17. So 7225 is equal to 5 multiplied by 5 multiplied by 17 multiplied by 17. So square root of 7225 is how much? Which is equal to 85. So our trick works. Okay, keep keep tuning for more tricks like this. I will try to teach you new tricks as we go along. Okay, I cannot schedule these tricks because these are surprise treats for you. Now go home and practice as many questions, factorization questions as you can. Take any random number and try to factorize it. Take your calculator, calculate a square, and try to factorize that square. You try to use these divisibility rules as much as possible. And if you want to go one step further, learn the squares of numbers from 1 to 20. It will help you a lot when you are doing these kind of factorizations and square root when we go and learn those. Till then, stay tuned, subscribe to my channel for more videos like this and for more updates. Till then, bye.